ओके वेलकम आम आज पढ़ा जाऊे +3 ऑर्गेनिक केमिस्ट्री गोटे इम्पोर्टेंट पार्ट है छोटिया पार्टे बट इम्पोर्टेंट SN1 SN2 जानला परे +2 लेवल रे सरी जाए किंतु +3 लेवल रे गोटे SNI रिएक्शन थाए ठीक अच्छे एटा होची इंट्रामॉलिक्यूलर कौन ना सब्स्टिट्यूशन न्यूक्लियोफिलिक ओके न्यूक्लियोफिलिक रिएक्शन ओके जब इफ this is so then we can say that here is a word that is called intramolecular means within a molecule okay this means the substitution nucleophilic reaction will be within the same molecule okay so we have to find out the nucleophilic attack position and attacking group means both nucleophile and leaving group are within the molecule groups are within one molecule okay or within same molecule. This is the important part okay the living nucleophile will attack the living group in the same molecule. Let us take an example so that we can see this reaction. Remember one thing, if higher concentration is taken then you will not get SNI reaction. So important is why I will say why I will discuss that one why low concentration is preferred. Important, remember in SNI low concentration is preferred okay why we will see. First let us take an example. What is that example? Consider the formation of your this molecule. See, tetrahydrofuran. Sorry, tetrahydrodioxane. Okay, oxane. This is a oxane. Okay, so this is a heterocyclic compound having an oxygen atom. Clearly, I can see there are 5 carbon chains 1 2 3 4 5. Start breaking this molecule so that you can get the nucleophile and the leaving group okay so from either side of oxygen you can break to think the starting point okay so here oxygen is electronegative so it will be minus means you are getting the nucleophile okay so my starting material will be having 5 carbons. One end will be connected to O minus and another end will be connected to the leaving group. Okay, leaving group. What are the best leaving groups? This is alkyl halide chapter. You can take as X as the leaving group, halogen. Okay, so here a O minus will attack at this center and the leaving group X, put it X here okay X will go as X minus. Clear? So now you can say this total mechanism is happening within this molecule to give what it is giving. See O, mark it 1 2 3 4 5 6. So 1 is connecting to 6. So this will become a 6-membered ring. How to know the ring size? By making the numbering. Always I will suggest please do numbering. Which position is attacking where so that you can attach them easily. Okay. So this is your compound 1 2 3 4 5 6. See, 6 membered ring, and X minus will be relieved from here. Okay, so this is the nucleophilic nucleophile. This is the living group. But what is the original compound? Just make it OH. Okay, what will be the original compound? Now make it OH. Here put Cl, here put OH. In this compound, just put little bit of OH minus or Et3, a weak base, so that it can take up this proton H plus and make the oxygen O minus. This will lead you to intramolecular SNI within the molecule substitution nucleophilic reaction. This is nucleophile substituting another nucleophile, so it is called SNI mechanism. Clear? Huh? Another example we can take up with your formation of this one. Suppose I have here NH. Okay, from where I can start? Simple way. Break from this side, so you will get H. Here will be a X group. So simple. Okay, this is the molecule. So let us start from the beginning. We are taking this one. Here N H H. Here you are having chloride. Okay, now here there is a lone pair. This will attack as a nucleophilic center. This will go as Cl minus. You are getting this one N H H. Here will be a plus. Okay, and C plus Cl minus is removed from that position. This is SNI. This is substitution intramolecular. Now the Cl minus comes here, attacks at the center, and the bond pair neutralizes the positive sign on nitrogen. So you are getting this product, tetrahydropyrazole. Sorry, pyrrole, tetrahydropyrrole. Why I am calling it tetrahydropyrrole? See, this is pyrrole. Okay, it is having two bonds. So to when you are reducing this one H will be added here, another two will be here. So tetrahydropyrrole. This is pyrrole. Okay, so knowing this much about SNI reaction, we can move forward towards, already we have discussed many things. Okay, now we are moving towards one of the important reactions, that is your benzene mechanism. In JAM, a mechanistic long question, everywhere you will find one question from this end. Okay, so let us discuss your benzene mechanism. Why benzene mechanism I am discussing, that is important. Okay, see, we have done many substitution aromatic. See, we have discussed this reaction. If you remember clearly, where is the duster? You have seen electrophilic substitution reaction. Those are nitration, chlorination, bromination, Friedel-Crafts alkylation, Friedel-Crafts acylation. Everything we have discussed in details. Okay, those were your electrophilic substitution. Okay, but have you heard about a double reaction? Double reaction means two mechanisms are involved in one reaction. Like I will say here, elimination and addition. Elimination, addition reaction. Two types of reaction we have discussed like this. One is your hydroboration oxidation. We will be discussing in alcohol. Okay. Another one is your, both the reactions are in alcohol. Okay. So we will discuss them later. This will be here elimination addition reaction. Okay. You have to eliminate one thing and add another thing. Okay. Let us take an example so that we can clarify the two terms. Okay. See, here I have chlorobenzene. Clear? Here I am adding KNH2. In KNH2, this is NH2 minus, this is K plus, this is Cl minus. So it will take up this one. Okay. What you are getting now? Now you are getting aniline from chlorobenzene. This is looking like another nucleophile is substituting this nucleophile, but generally in this ring pi bonds are there, so negative ion cannot attack here for substitution nucleophile reaction, nucleophilic substitution reaction. The ring prefers to go in electrophilic substitution reaction. But we are doing here, saying here, this is nucleophilic substitution, which is quite difficult. Okay. Rather, I will say it is rare. In case of vigorous condition, only nucleophilic substitution occurs. But this reaction is elimination addition. This occurs very easily. Okay. And you have to remember, see, this is KNH2, so you have to maintain NH3 solvent, not in aqueous medium. Okay. This is called elimination addition reaction, and the mechanism goes via, mechanism is very important. This is called mechanism goes via the intermediate. Which one is the intermediate? Now benzene. Most important thing, benzene. What is benzene? You know benzene. Benzene has double bond. Here you see the word YNE. So benzene is a triple bond compound. See, the carbon having a benzene ring having a triple bond. This is called benzene. Okay, this will be the intermediate. Okay, on the basis of this name, this mechanism also called benzene mechanism. Clear? So let us see what is the mechanism. For mechanism part, we have two steps. First step is your elimination, second step is your addition. Okay, so let us go to step 1, that is your elimination. Okay, elimination. What will happen in elimination? See, you have this chlorobenzene. Take chlorobenzene, but put double bonds in the ring. Here is chlorobenzene, here is a hydrogen. Okay, in the first step you are giving NH2 minus. Remember, you have K plus NH2 minus. So this NH2 minus will take up the proton. Here is a bond pair. This will move to this double bond, and this chlorine will be removed to satisfy the valency of carbons. Okay, so you are getting this structure. See, here double bond are there. Here you have already one bond. Another bond is coming, so it will form a triple bond. Clear? So this is the, in stepwise manner you also can do it. Okay, this is your benzene. How we are going to do in the stepwise manner. See, first don't do this one. So take this proton and bring this bond to this carbon center, so that you are getting this one stepwise manner. Okay, here is a double bond, here is a minus, here is a chlorine. In the next step you rotate it, just the same thing we are doing in stepwise manner. You rotate this one, it will the chlorine will leave as Cl minus, so you are getting the same benzene. Okay, another intermediate step I have just written. Okay, simple. You can draw directly also. This is the concerted mechanism method. Okay, both are correct. Whichever you write, it is okay. But remember, this benzene is very unstable. Unstable means you can trap this, but cannot put it for a long period of time. You cannot store it in a bottle. Okay, so instantly see, you are getting Cl minus, you are getting Cl minus, you have NH2 minus. See what is the trouble now for the second step. Okay, I am writing here step 2. You can write in the below step. Okay, step 2 will start from benzene. Okay, here two possibilities are there. See, you have taken out Cl minus, yes or no? Means here you have a Cl minus. Okay, this Cl minus is a nucleophile also. Another one you have already NH2 minus. Which one will attack here? This is the question. Okay, if we can prove that any one of these have higher concentration, means if it is has 10 molecules or 10 ions, but it has 1 crore ions, which will preferably attack? The more one will preferably attack. Or you can say if it is more, it will attack. Okay, so let us prove which one is more here. See, here the role of solvent plays a crucial role. See, you have NH2 minus. In which one? NH3. So NH2 minus in NH3, I can write this one as NH2H NH3. Okay, so it will take this one and you will get NH2 minus again. So it is continuously, repeatedly forming NH2 minus plus NH3. So your NH2 minus is plentifully available due to the presence of solvent NH3. Clear? If this is so, then which is more? The NH2 is more. Which is less? The Cl is less. Cl minus is less, because Cl minus you are getting only from the reactant. Okay, so now if this is Cl minus and this is NH2 minus and this is more, so we will get the attack from NH2 minus only. Clear? Up to this much clear? So I will not write both one, I will write just NH2 minus in the second step. For understanding, I have just written that one. Okay, now NH2 minus will attack where? Two positions are same, all the positions are same. Here it can attack or here it can attack, both are good. I will attack here, so this will go here. Simple. Step 2 begins from here. Okay, so what you are getting? Double bond, here is NH2, here is a double bond, and you are getting a minus sign in the first step here. Means beginning of the second step, you are getting a minus sign. Okay, what will happen in the next step? Now you have NH3 as solvent, so you give NH3 as this one. Write this NH3 as HNH2, so that this minus will take up a proton H plus, and this will form another NH2 minus for this reaction. Okay, so and your K plus will be removed as KCl. So you can write here the products are this double here NH2 plus what is happening? Now NH2 minus plus KCl, sorry, NH2 minus and KCl is formed. This is your aniline. This is the benzyne mechanism. Okay, it has many more implementation. Okay, one of the most important thing I want to share with you now, that remember, this is an intermediate. This is the benzyne intermediate. Okay, what is called intermediate? We have discussed in lesson 1, lesson 2 that intermediate can be isolated because it has a little bit higher lifetime. Okay, so it has a good lifetime. We can isolate this one for little amount of time. Okay, so which reagent is used for trapping? Okay, see, important thing. This step is eliminating Cl minus. So first step is your elimination. Okay, this second step you are adding NH2 and another H. Okay, if you are not adding this H, then it will be called as a substitution reaction. As you are adding total NH3, see here NH2 is added, here H is added, means NH3, a whole NH3 molecule is added. So this is your addition step. Okay, why it is called addition step, you know? Why it is not called substitution step, you now got the answer. Okay, now I am coming to the isolation or trapping of your benzyne intermediate. Okay, see, what is this trapping? Means you have to trap this benzene. Clear? Another thing I will say, but first remember this thing. Here you have a benzene. Clear? This is your benzene. You have to trap this one. Where it can react? Now it can react at a isolated type double bond. Okay? Or which can form a very complicated big molecule so that it cannot break, that kind of molecule. Okay, so where we will find that molecule? Simple. Let us react this one with your anthracene. What I am saying, clearly listen. This is anthracene. This is this is, if one ring, benzene, two ring, naphthalene. If three rings are there, this is anthracene. Okay, so put double bonds here, double. Clear? Now see what is happening. You add this bond to this position. You add rotate this bond to this single bond. You add this bond to this end, means this end is attacking here, this is rotating here, this is coming to attack here. This is the role of benzene on anthracene. This is called trapping of benzyne intermediate. Okay, clear? So this is your benzene. You are using anthracene. Okay, now see what will be the product. Little bit tricky, but you have to practice because this is a must question in any entrance and in any of your subjective writing questions. Okay, a famous compound. See how to write this one. A very simple technique I am saying you. Just see this ring. This is a benzene ring. Write this benzene ring like this, as it is written. Okay, this is a benzene ring having a double bond here because this is shifted here. Okay, write this ring at a distance from this ring. Okay, now see in between these two rings there are two carbon centers. Okay, join them. How? Now this is written as this one. Put this one. Sorry, my bad. Join this one. Okay, the upper part is finished. Okay, the lower part is like this, V. Make it A, means like this shape, parallel to this one. Okay, now you have both the carbon centers. Yes or no? Clear? Now this position and this position, these are the two positions. These are connected to this ring. Okay, these are connected to this ring. So you will have a bond between this and this, means this, and I will put a benzene ring here. Make it horizontal. Okay, here is the double bond. Just rotate it. So this is the double bond here. Here are two double bonds. Clear? This point will be connected to this one. So join it. This point will be connected to this one, means this point is connected to this one. Join this. Okay, see, easy. Again I am writing for easy learning. Put two rings just away from each other. Okay, now join them like this. Okay, now draw a partial horizontal ring, benzene ring. Join one end here, join one end here. This is all about this structure. Okay, now see, the benzene is trapped with anthracene, means it is forming a stable compound. If this is formed, then only you can say this reaction is going through benzene. Okay, so this compound has a famous name. Its name is trypticin. What is the name of this compound? Trypticin. Okay, very famous compound. You will get this compound when only benzene reacts with anthracene. Clear? So in the exam it is asked how to trap, or in the interviews it is asked how to trap benzene. Okay, you have to write this reaction, or sometimes in the short questions or objectives, the compound formed by the reaction of benzene with anthracene is known as dash. Four options will be there. If you know this is trypticin, you know the structure of trypticin, then only you can write this one. But important thing, I am now going to say you one thing. Okay, this is all about mechanism, benzene mechanism, but we will come to the application in the next class. Very important applications for JAM specially. Okay, without that mechanism you cannot write any of the benzene mechanism. Tomorrow class will be very much vital. Okay, see, if I have this compound, double, here is a Cl, here is a CH3, here is CH3, means this Cl is hindered, means bulked or surrounded by bulky groups like CH3 or C2H5. Okay, in this case if you give KNH2, you will be thinking that it will form a benzene here or here. Okay, but it will never form a benzene, so it will give no reaction. Clear? Okay, this is the exception. Okay, this much is for today's class. Tomorrow we will find major products of benzene mechanism. How to write the major products. See this, write this in your copy, show it to me.